Now, smile. Okay, now, we are just gonna, as I said, for tomorrow, just because we missed a couple of first minutes to record the session, I'm just gonna repeat this. Then for tomorrow, remember, using the direct definition of the derivatives, it means that using the limit function to find the derivatives. Do some more practice. You have done a lot in the class, but that's the thing which also it is good if you do that. Now, today we are going only to cover one question, one very interesting question, and finish the day just by one question before we say goodbye. Now, guys, today I'm just going to give you one example, and this example is this. I give you one function, and I said that function is this x plus 1 over x minus 1. And the class is finishes by 2:10. Half an hour is a good time. Now, the thing which I want to do is, yes, I say that, guys, please, everyone, listen. It is a very important example that we do today. If you do not learn it, I'm sure means that you know it by yourself. Okay, now, I give you this function, x plus 1 over x minus 1. What do we do is that I ask you, please find the tangent line at the point which is going to, both the tangent and the normal. Tangent and the normal at point which is x equal to what? X equal to 2. That's what we want to do today for the next half an hour. And that thing is going to be very, very interesting. Look at the colors of the trees. I'm a source of distraction myself. I'm a huge source of distraction. Now, why don't I just try to erase the board to give it a couple of minutes to see that what solution you can think. Sorry, what? Derivative not be that formula, the limit, based on the things that you know, for example, these ones. Not that definition of that limit. It takes you such a long time. Okay. Okay, now. Okay, before you start, you can also follow me and just help me just put that on the board. This is very important. This function is very important because I'm just going to introduce you to an easy method to find the derivative of this function. So far, what we have done was that when we're looking for the derivative of the function, we said that if we have, I'm just going to write some of the things that we said. We said that as a first formula, if we have a power function, the derivative is a n x n minus 1. If we have a composite function, then we do the same thing. Also, we said that if we have a product of two functions, which it means that f of x is multiplied to g of x. Let me see if I didn't record it on the camera. Okay. Then if we have that case, you learned it, that we say that the derivative of the first one times the second one, which it means that g of x times d over dx of f of x plus the derivative of the second one times the first one. Okay. right now, I see a function which I wonder which method do I have to use. This one doesn't look like any of these ones. That's the power rule, that's the composite rule, and that's the product rule. I look at this one, I say, oh, wait a minute. This format doesn't look like any of these ones. This one is a product. The closest one to that is this one. This is a product. Two functions are multiplied, but this one is two functions are divided. Then what do I have to do? We just start by two different methods. The first one and the second one, specifically focus on the second one. In 2 minutes we are getting there. The first thing which I can do is this. I say, if you remember, guys, from prior years math, we have always said that if we have A divided by B, we can take the one at the denominator to go up by just changing its exponent. That's something we can just close our eyes and write it without even single second hesitation. Now, I'm just going to use that to convert this one and bring this up. That's the first method which I'm going to use. X plus 1 times x minus 1. But at the same time, I notice that I have to put one minus there. Why? You ask me why? Then I have to tell you, my friends, that's the reason. Now, when it's like that, you say, wait a minute, does it look like something like this? Two functions are multiplied? So yes, you're right. Now we have a product of the functions if I take the denominator to the root by just giving this one negative. Now, in order now to find the derivatives of f of x, I'm just going to use this one, use this method. I say the derivative of the first function, let me be a little bit more artistic, use two colors. And I say, now, the derivative of the first function times the second one, it means that x minus 1 minus 1, derivative of d of x of x plus 1. What have I done so far? I used the first part of the product rules. I know that I have to plus it. I have to give plus the derivative of the second function times the first. It means that now I have x plus 1, which is multiplied to d over dx of x minus 1 to the power minus 1. So far, so good, everyone? Yes? Now, look at this one now. It seems that we have now a walnut and a hammer. If I give you a hammer and a walnut, what do? You smash the walnut. And that's what I'm just going to do with this derivative. I just smash it on the head of this walnut. Which it means what? Which it means that I have x minus 1 to the power minus 1. Hi, oh my God, look at who is here. I just asked, people were really missing you, and I know that she was so busy, I had to come to the class that we can say hi again. And ladies and gentlemen, Jessica.
Thank you.
She said, prepared a card.
Yeah.
A card.
Oh my God.
But that's because of the COVID, we do not have it. I bring it for a kind of sterilized format into your office from the students. Because I thought that because of the COVID, we do not have it. Because my hands are not the students but I really need sanitizer. If you want, yeah, anytime. People are so excited. Guys, everyone says hi to Jessica. Hi. Oh. And just what the funny thing is that you are being recorded. You're live.
Oh, that's very high. Prosperity.
Yeah, thank you very much, really. When I was talking to the students, they said that they all really miss you. That's really my dad showed up.
I'm here.
Oh, I do not have the confidence to teach.
Oh, no.
The great teacher is here, I don't have the confidence. Okay. Now, please. I'm just going to post it on the Google Classroom. No worries. But please make sure to watch it. Okay, now, the other thing which I do, I said that, okay, I have these formulas, and I have that time and I smash it. But this operator, which rule is it's going to be more relevant to that? The first one, I say that the derivative of the x becomes how much? 1. The derivative of 1 becomes how much? 0. Then it means that d over dx of x plus 1 becomes 1, which is multiplied to that term. I do not write that anymore. Now, I have plus. I have x plus 1 now, which is, we are going to take the derivative of x minus 1 to the power minus 1. Now, you ask yourself, but you should not ask Jessica for the answer to cheat. You have to come with the answer yourself, that which one of these rules is going to be more relevant if you just want to take this derivative of that function. 1, 2, 3. Don't look at Jessica for the answer. Say yourself. Yes. Second, if you do that, look at that. The n is how much over there? Minus 1. It means that then you have, I'm just going to write that in red, minus 1. Now, I have the n taken out. It falls behind that function. Then I have f of x. What is my f of x?
X minus 1.
That's so true. X minus 1. And n minus 1. N is minus 1 there. Minus 1 becomes how much? Minus 2. Now, am I done?
Yeah.
Who said yes?
Yeah.
Then we can talk further. Yes.
I said yes because the derivative inside the parenthesis is 1.
Oh, very smart. Very smart. One step ahead of me. Thanks. Yes.
Why do we determine the over next and plus 1?
You mean this one?
Yeah.
Let me look at it here. Can you look at this?
Right. So when you're not, because the derivative of x is 1, it's when derivative is 1, 0. 1 plus 0 is 5. Because it's, no, because x to the 1, right? So it's,
Tony, I have a little number also. Yes.
no. Well,
I'm just going to go the second step there.
yeah, it's the second. 1 times x times 1 minus 1.
Oh.
That's right.
1 has 1 and 0. Or it's x to the 1 minus 1.
Oh.
And now, I said that the derivative of also this term, d of dx of f of x, which is d over dx of x minus 1, the same thing as d over dx of x plus 1 is also 1. Then it seems that I have to multiply these to 1, which I'm not going to write. Now, seems that everything is now handy and we have all the things that we needed to just work with. But I'm just going to do some kind of, I should say, housekeeping. The first one which I have here is 1 over, look at this one. x minus 1 to the power minus 1, based on this identity that we saw, I can just take the downstairs. Becomes x minus 1. I have a plus term, plus this minus comes to this one, becomes minus x plus 1 over the minus, I should say, exponent, they all just go back where they were before. Because you see that these minus exponents are those terms that you have to just be the one upstairs. Then I bring them down there. It becomes then x minus 1 to the power minus 2. If you stop even here, that's totally fine, you get your mark, but I continue that further because I want to compare my result with the second method which I'm going to put here. Then as a result, you see that if you just want to add these two terms, let me just plus minus, you see that the common denominator is how much? X minus 1. But also, look at this. It should be positive. 2. Then the first term, you get x minus 1. Because you have to multiply this one to the x minus 1 to get there. And also you have what it comes by, minus x and the minus 1. I hope if I write here, you guys can see that, huh? When you write it here, it's so much caution. You see that there at the back? Yes. And now look at this. Then we have x minus 1 to the power 2. And also x minus x becomes how much? 0. Then I'm left with minus 1 becomes how much? Minus 2. Then you see that either you stop here or you do some more housekeeping together, both of it's fine. That was the first method, which I wanted to show that I use this identity to convert this one into this product format, then using these items one by one. Yes?
How did you, I don't understand what you did there.
This one?
Yeah. Did you simplify the second fraction or did you multiply the first one?
I get the common factor as x minus 1 to the power 2. Then I see, okay, there's a common denominator, this factor is missing. Then I multiply this one to x minus 1. I get x minus 1. Then for the second one, the common denominator is x minus 1 to the power 2. It means that I have to multiply 1 only to its numerator to get that one.
Oh, I see,
Minus x minus 1. You got it?
Yeah.
Fantastic. Guys, as I'm just going to talk to Jessica for a second, please also use this one to find the equation of the tangent and the normal at the point x equal to 2. Yes?
Can I, it's okay. It doesn't need to be in the whole class, but can you simplify the second fraction? Because minus 1, oh, never mind. It's x plus 1. Never mind.
That's fine?
Yeah, never mind.
Look at this one. The numerical result, it gives you the slope of the tangent minus the normal is going to be 1 minus over the slope. And then I just give you the second method. Jessica, thanks for the patience to listen to me. That's I know I'm a boring guy.
I'm coming to check on you. I'm coming to check on you.
I don't understand why he's simplifying that.
Dude, it's basic.
I know, I'm saying, why did he put it like that? Why wouldn't he put this, x minus 1, parenthesis, times 1 plus x plus 1 times x minus 1?
What are you talking about?
This line.
And what they need to walk.
What do you mean?
Using my office.
Did I write on this?
You have to kind of go over the tape. You can. Otherwise. It's so fun.
So, ladies and gentlemen, it warms my heart to see you in good hands. I wanted to come in and check on you, make sure that things are going well, and good luck tomorrow, March 1st yeah. Alright. Well, good luck with it, and thank you for the card. Help you.
Thanks so much for your time. Thanks, Jessica. Bye, Jessica, everyone. Bye.
Bye.
Thanks a lot, Jessica. Thank you. Now, guys, now, when we use the first method to yes.
Or when you simplify it, we're going to be a negative one. Why you factor in?
Negative 1 minus
Is this
minus
not
1 is going
that it's
inside.
not?
Oh, I see.
That's right.
You guys did that.
And now,
No, look.
what do I want to do? Okay, guys. Now listen. Now I'm just gonna give you this. Yes.
Oh, yeah.
Yes. Oh, sorry.
Took one out. Minus one.
You took out x, you took out x minus 1 to the power of x.
Oh, this is times minus one. So this is minus x squared plus one.
Yes. Only one.
So it's x squared plus two.
65 minutes. No good news, guys. Tomorrow there is no calculator part. Now, guys, now that we are there, I'm just gonna. I have 15 minutes left. In this 15 minutes, I'm just gonna give you one more, I should say, formula that you say, oh my God, is that guy insane? Look at this. Am I insane?
No.
But you literally say, is that guy insane? Doing all this way and look at, oh my God, it's a kind of headache. I want to go that way. I don't want to do that. You ask, is there any other way to do this that I get the same result? I said, do not worry, guys. You are. Hi, Beth, how are you? Good to have you here. Yeah. Well, thanks for coming to the class. Because I skipped it, but thanks. Means dedication to the calculus. Thank you, Kevin. You're just right at the right time, Kevin. Because I gotta cover one important formula. Then I say that no worries, guys. You still can get the same result, but using this formula. I'm gonna write this. Everyone, please take your notes. I think I have 15 minutes almost, huh? Less, 12 minutes. Look at this. I'm just gonna write this one here. Yes, I'm in that. Instead of having the products of two functions, then deciding to find the rate of change, I say I have a ratio of these two functions. D over dx of f of x. What am I doing? I say d of x of f of x over g of x. This is exactly like this. We have x plus 1 over x minus 1. We have f of x over g of x. Sometimes you say that in order to get the derivative, I take g of x as a product with the negative exponent. But I tell you, do not bother with these methods. I give you this formula, which gives you the same result. I say the derivative of the numerator times the denominator. I say g of x, d over dx of f of x. Look at this. It seems, oh my God, this is exactly like the product rule, but with a minor difference. That instead of plus, I say you put minus. Because look at this, this is a ratio. That's how I just memorized it myself. Then the second function, derivative times the first one. Look at this. The numerator seems exactly like the product rule, with a minor difference. That instead of plus, we have a minus in there. Yes? So far, so good? Now, what do I mean by having a ratio here? I mean that you take g of x, which is at the denominator, you square it. Beautiful, huh? Now, as an example,
It's not.
yes.
No, seriously.
And now, guys, I'm gonna do the same thing with this method, but not taking these kind of insane, crazy calculations. I'm just gonna use this method. And we compare the results. X plus 1, x minus 1. Okay, now I'm just gonna follow this method. F of x, g of x. I say the derivative of f times g. My g is x minus 1 times d over dx of x plus 1. I say minus the derivative of the new denominator times the numerator, which means that now x plus 1 times d over dx of x minus 1. So far so good. That's like a product rule, but we have a minus there. Now, I divide this to the denominator, which is gone to the power 2, because the formula tells me that to do 2. Any questions, guys, so far? No? Then I'm going to continue further. I have from the numerator, I have x minus 1. Again, the old thing that we do. d over dx of x plus 1. How much is this? 1. Then I get minus x plus 1. The derivative of x minus 1. How much do you get? 1. Over x minus 1 to the power 2. Now, you say that, wait a minute, it seems that we are getting there. I have x minus 1 to the power 2. Look at this one. It's easy to find this subtraction. X minus 1 minus x plus 1. How much do you get? X minus 1 minus x minus 2.
Minus 2.
That's right, minus 2. Oh, guys, look at this. Oh, I can't believe this. Compare these two results. Aren't they the same?
Yeah.
Yes. No count? No, we can read the calculator, but you do not need that. There is no two papers. One without the calculator, the other one. One paper, 65 minutes, no need to use the calculator. You can bring it, maybe you need it to just multiply two big numbers together. The basic calculator is enough. Yes?
Are there going to be any word questions on the test?
Any what?
Word questions, so like different scenarios.
Oh, no, I don't. No.
No?
Just basic calculations like this.
Okay, so with numbers.
Find the tangent, find the normal, and this kind of stuff. Find the derivative using, for example, the definition of the derivatives, finding the limit, those kind of stuff. No crazy stuff. Now, guys, we have how much time? 10 minutes, huh? 5 minutes. Then now, look at this. Add this formula here as a fourth one, because this one, you see that when two functions are divided, the second method is much preferred, because it's much easier than taking that route. Everyone is fine with this? Now, we finished today by one simple task. I asked you to find the equation of the normal and the tangent. If x is equal to 2, what is its y counterpart? You put 2, 3, 2 minus 1, that's right. Now, in order to find the slope of a tangent line, I'm gonna write it here. Let me see. Yes. The slope of a tangent line, guys. The tangent line, within 3 minutes, I'm gonna finish. It's ax plus b. You have to find the value of a and the value of the b. I told you also yesterday, the value of the a is how much? The derivative evaluated at the point 2. It means that minus 2 over 2 minus 1 to the power 2. How much do you get? Minus 1 over 2, huh? Oh, no, sorry, minus 2. If this is the slope of the tangent line, the result that you got as a derivative, you evaluated at the point which is given. Then what is the slope of the normal? Huh? That's right, because the normal, if I call that a prime, is minus 1 over a, which is minus 1 over minus 2, which is 2.
As 1 over 2.
That's right. Oh, 1 over. What number? I can give a prize in math that 1 over 2 equals 2. They have to give me a prize. I show that 1 over 2 is equal to 2 guys. Now, in order to find the b, how to find the b? Easy. I have the same point, 2 and 3. I substitute there. Y is equal, look at that, y equals to minus 2 times x plus b. Y is 3 minus 2, and how much is the x? 2 plus b. How much is b? That's right, minus 4. B is 7. Then it means that the equation we finish by this. The tangent line is given by this formula. Y equals to minus 2x plus 7. For its normal, you do the same method, but its slope is 1 over 2. And now we are done. Since that we are done and we are ready for tomorrow's test. Any questions there? No? Yes, yeah, No, not the inverse. The inverse of the slope. If the slope is, for example, the slope is q, it means that, guys, look at this one. I just explained that very quickly. The slope of the tangent, if this is minus 2, the slope of the normal is the minus inverse of that. It means that then the slope of the normal is 1 over 2x plus b, and you find the b as the way we should. It means that when you multiply the slope of the tangent to the slope of the normal, you should get minus 1. And that's the definition of the normal and tangent. Yes? Everyone is feeling happy now? You are ready for tomorrow's test? If you have any questions, please send me an email. Otherwise, I see you tomorrow. Great session, guys. Thank you, everyone. And also,